Let's see laws of exponents. In the previous classes, we have studied a few laws regarding exponents. The first, let us see those. The laws of exponents for any non-zero integers, for any non-zero integers a and b, and m comma n are any integers then the laws are as follows. So the first one, so we can call this as product rule, that is a to the power of m into a to the power of n is equals to a to the power of m plus n. And the second rule, power rule, a to the power of m whole power n is equals to a to the power of m into n. And the next rule, quotient rule, a to the power of m by a to the power of n is equals to a to the power of m minus n. Here if m greater than 0, and a to the power of m times b to the power of m, that can be written as ab whole power m, and a to the power of m by b to the power of m is equals to a by b whole power m. And next thing, a to the power of 0 is equals to 1. So these are the laws basing on positive exponents. So you learn these laws in the lower classes only for positive exponents. Now in this chapter you are learning already a few negative exponent laws. Let us see those laws. This is what the laws of exponents. Few more laws are there to discuss. Let us discuss those laws which are on negative exponents. So once again I brought laws. A by m, a power m by a power n is equals to a power m minus n, where m is greater than n here. And second one, a power m whole power n is equals to a power m n. The third one, a power m into b power m is equals to ab whole power n. And the fourth one, a power m by b power m can be written as ab whole power m. And the fifth one, a power 0 is equals to 1. And we can write a power m into a power n is equals to a power m plus en. So next, let us see a few more laws. See that if same thing, if a power m is equals to a to the power of n, then the both exponents are equal, that is m is equals to n. And already we know that a to the power of minus n is equals to 1 by a to the power of n. So the next one, we can use this formula vice versa, and a by b whole power n or m, that is minus m, then that can be written as b by a whole to the power of positive exponent, and a power m by a power n. We know if m is greater than 0. What if m is less than n, we can write it as 1 by a to the power of n minus m. So these are the laws of exponents so far which we have, which we are going to use this laws, and we can derive even one more from this. A power m by a power n is equals to 1 if m is equals to n. Why? Because this both will cancel and you'll get remainder 1. These are the laws of exponents. So using negative exponents. Got it? This is what the basic laws to solve all the exponents problems. So if you learn this laws, you can solve any problems. So practice these problems. What you have to do is, so you have to practice all. So practice in homework. So all these problems you have to practice in homework and copy these laws in CW. Practice thoroughly till you get these laws by heart. So let's go to few problems. So we are entering into the problems using the laws of exponents. Let's get started. The first problem this is, so what he gave is simplify and express the following as single exponents. You have to express it as single exponents. So 2 power minus 3 into 2, take the first one. So 2 to the power of negative 3 into 2 to the power of negative 2. Using class, you have to write as a single exponent. So for that, what I know is, I know that a to the power of m into a to the power of n is equals to a to the power of m plus n. So we know that rule. So I'm going to use this. So to find this, so this can be written as 2 to the power of negative 3 plus minus 2. That is equals to 2 to the power of minus 3 minus 2. Plus of minus is minus. That can be written as 2 to the power of minus 3 minus 2 is minus 5. So we have done with the answer. So the answer is simplified and we have written in single exponent. So here the second one. So here I'll take the second one. 7 to the power of minus 2 times 7 to the power of 5. Clearly observe that here the bases are equal and powers can be added. So here the rule, bases are equal, powers can be added using the same rule. 7 to the power of minus 2 plus of 5. So that can be written as 7 to the power of minus 2 plus 5. So minus 2 plus 5 gives us 7 to the power of 3. And take number 5. So here is the number 5. So m to the power of 5 times m to the power of negative 10. That can be written as same thing, bases are equal, so powers can be added. 5 plus of minus 10, that is equals to m to the power of 5 minus 10, that is equals to m to the power of minus 5. So we have written as a single exponent for all the problems. So what are left with this? So these are the left one. So do these as homework. This is your homework. Do this as homework. Let us extend our work with few more examples. So same thing. Simplify and write as exponential form. So I'll take the first one. What is the first one is minus 2 to the power of minus 3 times minus 2 to the power of minus 4. So take these two. So again same thing that I know that. So a to the power of m times a to the power of n can be written as a to the power of m plus n, where m comma n are any integers and a be any non-zero integer. So that we got minus 2 to the power of minus 3 plus of minus 4. Now simplify this. Minus 2 to the power of minus 3 plus of minus is minus. This is equals to minus 2 to the power of minus 7. This is the answer. And I'll take number 2. So what number 2 is given is number 2, p to the power of 3 times p to the power of minus 10. So that is equals to same thing, p to the power of 3 plus of minus 10. So p to the power of 3 plus into minus 10. So small to big subtraction, the result is minus 7. This is what I have written in single exponential form. So this is your homework here. So do this the remaining problem homework. So the same rule is applicable for that third problem also. That is when bases are equals, the powers can be added. So the rule is when bases are equal. So here's powers can be added. Okay students, got it? Let us check out here a proof of the law, that is if a to the power of m is equals to a to the power of n, then m is equals to n. So how I have solved this is, so see that so where a is any non-zero integer and a should not be equals to 1 and a should not be a negative. So keep in mind that a should not be 1 and a should not be a negative number. So let a power m is equals to a power n. Then so transpose a power n to this side, that can be written as a power m by a power n is equals to 1. So dividing both sides, say a power n, both the things are same. So what I can write is, so we know that if a to the power of m by a to the power of n is given, we can write it as a to the power of m minus n. That is the thing is here written. So a to the power of m minus n is equals to 1. So already you know that 1 can be written as a power 0. So a power 0 is equals to 1. This is replaced. So if you observe that both sides, so both sides bases are equal. Both sides bases equal. So bases equal. So here the powers can be equated. So m minus n is equal to 0. So transpose n to RHS side, will get m is equals to n. So therefore the condition is being derived as if a power m is equals to a power n, then the result is m is equals to n. Here is a proof for this. So here I would like to ask you that why a should not be equals to 1. So if y is if a is equals to 1, then what happens? So take one example by taking a is equal to 1. Say some m is equal to 7 and n is equal to 6. So try to substitute in that. So what happens here? 1 power 7 is equals to 1 power 6. So 7 is equal to 6. This is absolutely a wrong statement. So this is a true? No, this is a false statement. So that's why a should not be equals to 1. If a is equals to minus 1, what happens? So let us solve this one here over here. So same example I'm taking. A is equals to minus 1, m is equal to 7 and n is equal to 6. So what happens here is, so a to the power of m is equals to a to the power of n. So replace that. Minus 1 to the power of 7 is equals to minus 1 to the power of 6. So minus 1 to the power of 7 is, if it is having odd power, the result is minus 1. If it is having even power, the result is 1. So negative 1 never be equal to positive 1. So this is a false. So that's why we take that a should not be equals to 1 and a should not be equals to negative 1. So understand students? This is the proof of this statement. So every laws of exponent can be proved with various examples and can be verified with different examples. Understand students?